Hi Evergreen. Let's do our chapter 3 summary and review. Get your book out and we're going to go over the terms that are on the left-hand side of our page. So the first thing we want to make sure we know and just review, I know this is old stuff, but it's very important that we know the types of angles that are in geometry. So we have our 0-degree angle, which means basically, that hasn't gone anywhere. It's 0 degrees. An acute angle is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is greater than 90, but less than 180 degrees. A straight angle is exactly 180 degrees. And then it starts going, if you imagine the hands of a clock, going all the way past 180 degrees. So we have a reflexive angle, and then a full rotation equals 360 degrees. It looks like 0 degrees, except it's gone all the way around, and that's why it has that circle showing you that it has moved all the way around. Another thing we want to talk about is the opposite angles. So we just want to make sure we know that A and B are opposite angles and they are equal to each other. Then we have A and B. If they add to 90 degrees, they are called complementary. And they're also adjacent because they're next to each other. So adjacent angles are next to each other. And then here we have our last spot is A and B. They are adjacent and they are also supplementary because they add to exactly 180. So here we have complementary adds to 90 degrees. Supplementary adds to 180 degrees. Let's go over some of our properties. So we have the addition property. If A is greater than B, then do you see that we've added A or a C to both of them? So if you add the same amount to both, it will be equal. So if you could imagine these animals on a scale, we have an elephant's weight is greater than a bat's weight. And if we add a monkey's weight to both of them on the scale, it wouldn't change anything because it is an equal weight being added to both. This is the addition property. It maintains the same inequality. We have subtraction, which is the same thing except the opposite operation happening. Instead of adding the same to both, we are subtracting the same to both. So if we start with a larger bunch of bananas being greater than a smaller bunch, and we take a banana from both, we still have the same inequality. Multiplication, same thing again. If we are multiplying by C on both sides, then let's imagine we have $20 and it is greater than $10, obviously. And if we multiply both times the same number, times 2, or whatever number, we will still have the same inequality. Division, exactly the same as multiplication, except we're doing the opposite operation. We're dividing both. So we'll take our same example. We have $20 is greater than $10. If we divide both by 2, we'd have 10 and 5, and we still would have the same inequality. Now let's talk about an axiom is basically a synonym for a postulate. So they are true without the requirement of proof. And these are different than theorems. Theorems have to be proved. So a postulate or an axiom is something like a fact, something that we accept. And a theorem has to be proved. This is another one of our big ideas that we covered is the betweenness of points theorem. So a point is between two other points on the same line if and only if its coordinates are between their coordinates. So here we have AB line segment is between the BC line segment. So B is the point that is between both of these. And of course, AB line segment, if we added it to the BC line segment, it would equal the total line segment of AC. So basically it is a point between two other points. That is like the simple way of saying that. Then we have the betweenness of rays theorem, and this is the same. It's making it sound very complicated, but it's quite simple. If we look at this total angle, AOC, and we see that in between this angle, we have a ray, which is OB. And we're learning that the OB is a ray between the angles. And if we added AOB, that angle, to BOC, it would equal the total angle, AOC. So this is a very fancy theorem, which is something that you would just already know instinctually. Oops, I skipped one, I think. Okay, let's go over how to bisect a line segment one more time because it's just so important in geometry. So let's watch this video really quickly and enjoy. Start with a line segment. Label your endpoints. You want to choose a width of your compass that is about 3/4 of your line segment. Make a mark on top and bottom from both left and right, and you have bisected your line segment. Okay, we also have how to bisect an angle using a compass. So let's watch this one. We start off with an angle.
About how to bisect an angle. So this is the angle here that we want to bisect or cut in half. And so what you're going to want to do here is you're going to want to take the point of your compass, put it at the vertex of the angle, open up your compass, and then draw an arc such that it intersects both sides of the angle. Then we're going to use these 2 points right here and here to draw 2 more arcs. So I'm going to draw an arc like so, go to the other point of intersection on the side of the angle, draw another arc like so. And now all we have to do is draw a ray through the vertex of the angle and then this point of intersection here, and that's going to effectively bisect the angle. So let's go ahead and do that. And that's it. You can see that this angle here and this angle here are congruent.
Awesome. So we have to always make sure we know how to bisect an angle, bisect a line segment. Now, when we have angles, they normally have a pair of relationships. So the first one are adjacent angles. We already talked about this one, but 2 angles that share a common ray in the middle of them are adjacent. That means next to each other. Vertical angles are angles that are across from each other. So we have 2 lines that are intersecting, and 1 and 2 are across from the same vertice, and so they are vertical. And then 3 and 4 are also vertical. And the one thing that we know for sure is that vertical angles are equivalent. So 1 and 2 are equal in their degrees, and 3 and 4 are equal in their degrees. Complementary, we talked about this earlier, add to 90. Supplementary angles, they are adjacent and they add to 180. Congruent is a word that you should already be familiar with, but just to refresh, they are coinciding exactly when superimposed. So basically, if these shapes were lined up on top of each other exactly, superimposed, they would be exactly the same, which means congruent. Okay? Corollary is another word that is the synonym to conclusion or consequence or outcome. Okay? It's the end result, corollary. So if we have this corollary of the acute angles of a right triangle are complementary, that means they add to 90 degrees, you could prove it by showing that angle D plus angle E equal 90 degrees. So that is your conclusion. Linear pairs, we already talked about this a little bit, but linear pairs are adjacent angles, that means they're next to each other, that add to 180. So linear pairs is a synonym for supplementary adjacent angles. We already talked about this, but just to be sure, the midpoint of a line segment. So a line segment that is bisected, cut in half exactly, M would be the midpoint. This is different from the betweenness because betweenness just means it's between somewhere. The midpoint means it is middle exactly. And then also we have, this is kind of like the betweenness theorem of a line segment. This is the betweenness of a ray. So if we have a line going line AC, you see that going both directions, and B is in the middle. It doesn't have to be exactly the middle, but it is in between. Then these are opposite rays. So basically, if we're only looking at ray AB, it is going to the left, and it is sharing the midpoint or the between point B. And so the ray BC is going forever to the right. And so since they share that point B in their rays, they're called opposite rays because from point B, they're going the opposite direction. Then perpendicular and parallel lines, you already know this, but just to make sure. And then we have the reflexive property. So this is a really easy thing that sounds super complicated, but basically it just means it's like a reflection. A equals A, 1 equals 1, 2 equals 2. Line or angle A will equal angle A. So it's just basically saying the same thing will equal itself. Substitution property. This means that A equals B, okay? Or whatever variable they give you. But they're telling you that you can substitute B and A for each other in an expression. So if we know that A plus 3 equals 8, and we just were told, given our, given right here, A equals B, then we know that we could substitute A for B, and B plus 3 would also equal 8. Therefore, we know that A equals 5 and B equals 5. So A equals A, 5 equals 5. This is one of those simple things that sounds more complicated at first. Substitution property. And then this is another one that sounds so fancy, the ruler postulate. But basically it just means that like a ruler has measurements, a line has measurements, and you can use them to compare numbers. So if A is on the 0 mark of our number line or ruler, and if we were counting these little lines, we would see that B was at the 3 mark. And so you could measure the distance. Just like in a ruler, you could measure the difference. You can measure on a number line as well. So you can use a ruler to measure. That's what this means. And then the same thing for the protractor postulate. It basically means you may use a protractor to measure an angle. And you can find the difference between angles, and you can find the sum of angles. And we're just talking about the tool that we use to measure, the protractor. Okay, y'all did so super. And I can't wait to see how you do on your test. If you have any questions, send me an email or talk to me in class. But I hope you have an awesome day. Bye, y'all.